Welcome to my video on the properties of logarithms. The purpose of this video is to help you become acquainted with the three rules that logarithms deal with, specifically the product rule, the quotient rule, and the powers rule. We're going to be going over the main definitions of the rules, how to change a log from one form to another using the rules, and then seeing how multiple rules can be used at the same time for one specific problem. Alright, so with that said, let's get started with the product rule. The product rule is as you see below. The log of base b of m times n equals the log of base b of m plus the log of base b of n. Basically, if you notice that your log is being multiplied, and this is the answer portion of your log, this isn't the exponent portion, but the answer portion of your log is being multiplied by something, you can separate them so that it has just the m and then just the n. The bases are the same, and if we are going from this form into this form, if we're going backwards, well, we have to make sure that both pieces have the same base. That is key. So let's try an example of going from this form into this form and then vice versa. If I have the log with base 3 of x times y, notice right here is multiplication. I'm multiplying the x times the y. So I can rewrite this using that product rule. This is going to equal the log base 3 of x plus the log base 3 of y. All I've done is split this apart into two separate logs, and notice how they both have the same base. That is going to happen. No matter what the base is over here, when you split these apart, that base will apply to both of them. And we are adding them. I know it's called the product rule, but that's because this is where the multiplication happens. And since it's happening over here, we have to add them together. Now let's say I had this, log base 5 of a plus log base 5 of b. Well, if you notice, this looks a lot like that. So if we were asked to condense this, we would put it back into a form that looks like this. And we know it's multiplication in the end because we have this addition here. So this is going to change into a single log with base 5 of a times b. So there we have it. We've gone from one form into its expanded form, and then we've gone backwards. We've taken the expanded form and we've put it back into the condensed form. That is your product rule. Alright, let's move on to the quotient rule. The quotient rule deals with division, and in this case you're going to see fractions usually. So here we have the log of base b of m divided by n, and this is going to equal the log base b of m minus, and that's key here, log base b of n. So, like the product rule, we are expanding this out. But since it's division, and whether we use the division symbol or a fraction, it turns into subtraction. That is a key difference with the quotient rule. We have to be subtracting one log from the other. So, if I'm going to see this in action, let's say I have log of, let's say, base 10 of a divided by b. If I'm going to expand this out, remember both logs have to have the same base. So both are going to have base 10, but one's going to be of log a, the numerator, subtracting the denominator, b. So it's the top minus the bottom, not the bottom minus the top. And there we go, we've just expanded it. The bases have to stay the same, and we're subtracting the numerator, then the denominator. Alright, What if we have to go backwards? Well, first thing we should do, check a couple things. Let's say we have log base 4 of x minus log base 4 of y. If we're going to check things first before we try to condense it, first we should probably check and make sure that the bases are the same. Since they both have a base of 4, these can be condensed. So this is going to equal the log base 4. Now, check your sign, because the only difference between multiplication and division with these rules is what operation is happening. Since this is subtraction, it's going to be division, and we will then write it as a fraction. So x over y. First number is your numerator, second one is your denominator. And that's the quotient rule. We've gone from expanding out one log into two separate logs, and then we've condensed two logs that have the same base into one log. There's the quotient rule. Alright, now for the powers rule. Our final rule we're going to discuss is the powers rule, which says if you have log base b of n raised to some power y, we can rearrange this so that the y goes in front, and now we're multiplying the y times log base b of n. So all we did literally was we took the exponent and we moved it in front. That's the powers rule. It says if you have something raised to a power, that's your answer, you can multiply the log base b of whatever by that. So let's try a couple examples. First, we have the log base 3 of x to the 5th. Well, that looks a lot like this, so what's going to happen to that exponent on the x? Hopefully you're saying it goes in front, and you're right. We're going to take that 5 and it's going to go in the front. And we're going to have 5 times the log base 3 of x. And we've just simplified that. Now if we want to go the other way, we can say, oh, let's say I have this problem. 2 times log base 7 of x. Well, if I want to rewrite it so that the exponent is on the n, I just have to take this 2 and put it on the x. So I can rewrite it as the log base 7 of x squared. There's your powers rule. It just talks about moving the exponent to the front of the log instead of being on whatever it was on originally. Now, sometimes you're going to have problems that use multiple rules at once, and it's going to be our job to either simplify or condense or expand, however the directions say. So let's try a couple where multiple rules will be happening at once. Our instructions here are to expand out the log base 3 of a to the 6th over b squared. Now before we even start it, take a look at the log we're being asked to work with. Hopefully you start noticing, oh, I've got two different rules that are going to come into play when I try to expand this. First of all, I've got the quotient rule, because I have a fraction here, something over another piece. So I'm going to be expanding it out using the quotient rule. But I also should notice that both my numerator and my denominator have exponents, which means that the powers rule is going to come into play as well. So I'm going to have two rules to take care of, and I recommend, in this case, take care of the quotient rule first. So if I'm going to use the quotient rule, I have to split this up into two different logs. So it'll be the log base 3 of a to the 6th minus log base 3 of b squared. That's taking care of the quotient rule because I've split it up into two different logs and I'm using subtraction. They both kept the same base as they should, and now I can handle the exponent or the powers rule because both of these have exponents. So all we're going to have to do is take the exponents and move them to the front. So this becomes 6 times log 3, or base 3, of a minus 2 times log base 3 of b. And now we have condensed this down as far as it can go. We haven't condensed it, we've expanded it out as far as we can go. We took care of the quotient rule, then we took care of the powers rule. Let's try another. This time we're being asked to condense 6 times the log base 6 of u plus 30 times the log base 6 of v. Couple things we should notice. One, both have the same base, so we know we should be able to condense it somehow because they have the same base. I've got a plus here. I'm adding these logs, which means what? What rule is going to come into play here? Hopefully you thought the product rule, and you'd be correct. If we're adding two logs with the same base, the product rule is going to come into play. But that's not the only rule, because look, I have a number multiplying the log and a number multiplying the log. So this is also going to use the powers rule again. So we have to decide what are we going to do first, and like the previous example, I did the quotient rule first to expand, then use the powers rule. Well, I'm going to go in reverse. I'm going to take care of the powers rule first, then use the product rule. So if I use the powers rule, this is going to become log base 6 of u to the 6th. I just took that 6th and moved it over, plus log base 6 of v to the 30th power. Once again, I just took the 30 and I put it on the variable. Alright, now that I have it like this, I can take care of the product rule since I'm adding two logs with the same base. So I can rewrite it as having just one log to the base 6, and it's going to be u to the 6th times v to the 30th. And I'm done. I've condensed this down as far as it can go using first the powers rule to get the exponents back on the variables, and then using the product rule to combine them into one single log. Alright, we're going to do one more example. It's the most complicated one we've seen, but we can handle it. Let's take a look. Alright, so in our final example here, we're being asked to expand the log base 5 of the quantity a to the 4th times b raised to the 3rd power. And what we should notice here is that we've got multiplication, so we're going to be using the product rule, but I have an exponent here and I have an exponent there. I'm going to have to use the powers rule twice. Now, there is a couple different ways you could think about doing this. You could use the powers rule or the exponent rule for exponents, but I'm going to stick to our method that we're using in this video, which is the powers rule for logarithms. And that's going to be the first thing that I do, because this is affecting both of those. I can't split this apart until I take care of that 3. So I'll first rewrite it as 3 times the log of base 5 of a to the 4th times b. So I've taken this exponent and moved it to the front. Now I have the product rule to take care of. I'm going to have to split this apart, and what's going to be different here from the others examples is it's not going to start off as just log base 5 of a to the 4th plus log base 5 of b. It's not going to look like that because I have this 3 here. It's 3 times the log of both of these. So I got to make sure that 3 comes along to both pieces. Now, this side's good. This side is taken care of. But I've got to handle another power rule over here. I got to move this 4 to the outside. And what do you think is going to happen when I do that? Well, if you thought you're going to have to multiply the 4 and the 3, you're right. So it's going to be 4 times 3 times the log base 5 of a plus 3 times the log base 5 of b. And the last thing we can do is actually multiply these out. So 4 times 3 gives me 12, and then that's 12 times the log base 5 of a plus 3 times the log base 5 of b. And that is our final answer here. So there was a lot of stuff going on. It looked kind of ugly, but following our rules step by step, we were able to handle it. Hope you found this video on the properties of logs useful, and good luck!